Lesson 4.5, Calculating the Length of a Leg. In the last lesson, we learned how to calculate the length of the hypotenuse of a right triangle. We will now learn how to find the length of one of the legs. First, we need to review a basic idea. That idea is called isolating the variable. So what happens when we want to know what a variable is equal to, but there's a number being added to it? To solve this, we need to isolate the variable, or get that variable or letter by itself. To isolate the variable, we need to turn the number being added to the variable into a zero. But remember, we need to keep the equation balanced. That means what you do to one side of the equation, you do to the other. So for example, if I have x plus 16 equals 25, and I want to know what x equals. So my goal is to isolate or get x all by itself. To do that, I need to get rid of the 16. I need to turn it into a 0. So how do I turn a 16 into a 0? Well, I subtract 16 from it, because 16 take away 16 is just 0. But if I subtract 16 from the left side of the equation, I have to do the same thing to the right side of the equation. So it looks something like this. X plus 16, and then I subtract 16, and that will turn into a 0. 16 minus 16 is 0. And on the other side of the equal sign, I have 25 minus 16, so that my equation is balanced. So I simplify this, so x plus 16 minus 16 is just x. And on the other side, I have 25 minus 16, which is 9, so x equals 9. Okay? I want you to try the first 3 problems, so in the left column, and do that isolating the variable and see how it goes. Okay, so A, we have x plus 25 equals 40. So we want to get rid of that 25 to get the x by itself. To get rid of the 25, we turn it into a 0 by subtracting 25. But what we do to the left side, we have to do to the right side as well. So this becomes x equals 15. For B, we have x plus 10 equals 35. So if we subtract 10 from the left to get x by itself, we must subtract 10 from the right, and we get that x equals 25. And x plus 5 equals 12. Well, if I subtract 5 from the left to get x by itself, I have to subtract 5 from the right, and I get that x equals 7. The problems in the second column are almost exactly the same, but this time the variable has a squared symbol. So we talked about that back in the last lesson when we were finding the length of the hypotenuse and we were eliminating the square. So I'll do one with you, and then you can try the other 2 on your own. So the first thing we're going to do is get the x squared by itself. So to do that in the same way we've been isolating the variable, we're going to turn that 4 into a 0 by subtracting 4. And we do the same to the other side. And we end up with x squared equals 16. Then we go back to what we did in our last lesson where we eliminated the square, and we take the square root of both sides. So if I take the square root of the left side, I'm left with x. And if I take the square root of the right side, I'm left with 4. So x equals 4. So we're combining the skill from the last lesson, eliminating the square, and the skill from this lesson, isolating the variable. So I want you to pause the video, try B and C, and then come back and see how you did. Okay, so let's have a look. So x squared plus 6 equals 31. So the first thing we want to do is turn that 6 into a 0 by subtracting. We subtract 6 from both sides and we get that x squared equals 25. And then we eliminate the square by taking the square root. And the square root of 25 is 5. So x equals 5. And finally, C, we have x squared plus 12 equals 29. So we're going to get the x squared by itself by turning that 12 into a 0. So we have x squared plus 12 minus 12, which would be 0, equals 29 minus 12, or x squared equals 17. Then we eliminate the square by taking the square root, and we get that x equals 4.12. So this skill of combining eliminating the square with isolating the variable is what we're going to use. It's the math we're going to use to solve for the missing leg in a right triangle. So the questions on the right side, the x squared plus 4 equals 20, x squared plus 6 equals 31, and so on. That's what the math is going to look like when we're solving for the missing leg. So how do we find the missing leg of a right triangle? We use an equation called the Pythagorean theorem. And just a reminder that the Pythagorean theorem states that a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the legs of the triangle. So find the length of the leg in the following triangle. So we have a hypotenuse of 5 and one leg of 3, and we need to find the other. So we're going to follow through the table that I gave you that has all the steps written on it, and we're going to find the length of the other leg. So step 1 is write the Pythagorean theorem, a squared plus b squared equals c squared. Step 2 is fill in the legs that we know, the leg that we know for A and the hypotenuse for C. So the leg that we know is 3, so that goes in for A. So we get 3 squared plus b squared, because we don't know the other leg, so it's still b, equals 5 squared, which is our hypotenuse squared. So the leg that we know goes in for A, the hypotenuse that we're aware of goes in for C, and we're looking for B in this case. Step 3 is to square both numbers, so 3 squared is 9 and 5 squared is 25. Step 4 is to isolate the variable. So we have a 9 that we have to get rid of to get b squared by itself. So to turn that 9 into a 0, we subtract it. So 9 minus 9 would turn into a 0, but we might subtract 9 from the other side as well to keep it balanced, and we end up with b squared equals 16. Step 5, we eliminate the square by taking the square root of both sides. And step 6, we state our answer. So if we take the square root of both sides, the square root and the squared on the left side will cancel, and we're left with b. And on the right side, we have the square root of 16, which is 4. So the other leg of that triangle is 4. So take a second and try this problem on your own. Use the steps in the table above and follow them to see if you can figure out the length of the missing leg in this triangle. Okay, so we state our Pythagorean theorem, a squared plus b squared equals c squared. We're going to fill in the leg that we know for A and the hypotenuse for C. So the leg that we know is 6, the hypotenuse is 9. So we get 6 squared plus b squared equals 9 squared. Then we are going to square our numbers. So 6 squared is 36 and 9 squared is 81. Then we're going to isolate the variable. So to make that 36 turn into a 0, we're going to subtract 36 from both sides. And we're left with b squared equals 65. Finally, we're going to eliminate the square by taking the square root of both sides. And we're left with a final answer of 8.06, which is the length of that leg, that missing leg. So I'd like you to go and practice this a little bit, finding the missing leg of a right triangle, and then we'll put it all together.